Hi, I welcome you back to this next part. I was kind of tired with the black and white, so I thought let's have some colors. I'm using a colored template for presentation. In this part, we will learn about scope. The word scope applies to variables. So I have wrongly written that variables have three scopes. Actually, variables have four scopes. It's a mistake in typing. They have global scope, file scope, local, and block. Static global variables have file scope. Other global variables have global scope. That is, they can be accessed in other files also. But if you make the same global variable static, they cannot be accessed in any other file. They must be accessed in the same file. Static local variables persist across function calls. I will show you the third point right straight away, except the static part, because multi-file compilation and all I have not covered. So I will be able to show you global, local, and block. Static I will not be able to show you unless we deal with function and multi-file compilation. When we will go through functions and we'll see at that time that how static variables persist across global calls of functions, and when we have global variables and multi-file code, we'll see how static global variables have file scope. So these 2 points I'll not be able to cover. I'm going to show you the rest of the elements. So I have created a project as usual, scope, and let me clean this up. So I clean this up. Okay. So I say variable int I. Now, if you remember my discussion on structure of a C program, I had told at that time that any variable which is outside all functions is global variable. So this I is global variable. Let us try to print this global variable inside main. What do you expect the value should be? I think it should be 0. Let's see. Okay, let me fix this as usual. Okay, now so I can put a form. It is 0. Global variables by default get a 0 value. Why they get a 0 value? There is a reason behind that. That is part of the memory diagram of a typical C program. I'll show you that memory diagram perhaps next time I show you my slides. So I have this global variable integer and I can access that name here. Now let's say declare another variable int j. Now What do you think the value of j will be? Well, I don't know. I cannot predict what the value of j is going to be, because in this case j lies on an area known as stack, and unless you initialize it with a value, you give it a value, it will continue to hold its pre-existing value and you will get most probably a garbage value. Let's see what that value is. So it is holding this value, and this value is garbage. We cannot make a sense out of it. So I is a global variable, j is a local variable. Now let's see what is a scope variable. Now see, this is the brace which marks the beginning of the function. So similarly, when I put another brace, then it marks the beginning of a block inside the function. And let's say I say int k is equal to 7, and then I say printf %d \n comma k. Now note that you can access the other variables also here, I and j. You'll be able to access, no problem. So we run it. Now you see I can access k here. The question is, suppose I go out of this block, can I access k here? No. You are not allowed to access k here because the lifetime of k ends here. After this block, k does not live. Why k does not live? That's a different matter. That's a memory architecture of C takes care of that. For now, rest assured that whatever variable you declare in a block, this is our block, and whatever variable we declare in the block, they do not live outside that block. It will give you errors. Another thing, you can declare k here again, and this k and that k are different. They are different k's. This is a function level k. Below this point you can access k in main anywhere. Now that reminds me a very good question. What if I say this? What do you think, which I will be printed, the global or local? Let's see. Whenever you will print a variable, then it will try to find that variable in the closest scope. Say, for example, first it will try to find in the block scope. If it does not find, then it will try to find in function scope. It doesn't find, then it will try to find in global file scope, and then it will try to find in the global scope. This is how C variables try to resolve their scope. And as I had said during presentation of slide, I will deal with static function variables, that is static local variables and static global variables, separately when we deal with multifile and functions. So for now that's it in scope, and we'll see these block variables. These are very important, and these were introduced in C99. Before C99 these were not there. They have very important efficiency reasons to be there, and they were introduced in C99 with a very specific reason being in mind, because They are typically used as loop counters, block variables. So your loop starts and ends and it goes out of scope, and then you save memory. So that's it for now. Keep coding, and I hope you are getting better by this time. Thanks a lot for being with me. See you in the next part.